Hello student, today we are going to study the topic Aldol condensation and what are the necessities for Aldol condensation. So this is another topic carbonyl compound and we are going to understand the reaction method very first. So first of all, here in this reaction there is a aldehyde or ketone. The numbers should be at least 2 and they get condensed in the form of alpha beta unsaturated hydroxy aldehyde or ketone. Okay, so let's write first of all two molecule of aldehyde or ketone get condensed to form beta hydroxy aldehyde or beta hydroxy ketone in the presence of base. Okay, so in the presence of base, our aldehyde molecule, ketone molecule at least should be number 2. Either one aldehyde, one ketone, or both aldehyde, both ketone, and it get condensed in the form of alpha beta unsaturated aldehydes or ketones as a aldol compound. Okay. So first of all, understand what is the primary requirement for the aldol condensation. So the primary requirement is alpha hydrogen, and how we know one molecule having alpha hydrogen or not. So first of all, write a molecule that must have a functional group, and in this topic our functional group is carbonyl. So we are going to discuss any aldehyde or ketone. Okay, so write a aldehyde, like I am writing here acetaldehyde. Okay, so this has how many alpha hydrogen? It has at least 3 alpha hydrogen. First of all, how we understand alpha hydrogen? This is our functional group. Okay, this is our functional group, and this is carbon attached to our functional group. So this carbon is known as alpha carbon, and this hydrogen is known as alpha hydrogen. Okay, so your alpha carbon and alpha hydrogen is in this molecule. So is this molecule is eligible for Aldol condensation? Yes. So this undergoes Aldol condensation and form a beta unsaturated hydroxy compound to be ketone or aldehyde. So let's write the reaction and understand our reaction mechanism. So according to the definition, we are going to use 2 molecules of aldehyde, which is your acetaldehyde, and then we are going to produce the aldol compound. Okay, so I am writing CH3, only one molecule here because first reaction includes formation of one nucleophile. Okay, so it is going to attack and form. Okay, so it will attack and form one negative charge here and one hydrogen will form one water molecule plus our nucleophile will be this CH3. So this is our nucleophile, and this nucleophile will be attached to the other molecule, which is your CH2, CH2. Okay, so this negative charge is going to attack here, and this one going to break into 1 plus minus. It will be our electrophile. First of all, it is our electrophile, get attacked by our nucleophile, and it is going to form a new compound, which is your aldol compound, and it is like CH3 Negative charge will be compensated by the hydrogen from this molecule and our one OH minus will be released here. Okay, this is not a complete reaction. This is just a Aldol compound, and where we are going to write the one hydrogen left. So you form one alcohol, one aldehyde in this compound, and this is your Aldol. Aldol molecule. Okay. You can name it according to the IUPAC rule, and this Aldol molecule is going to be condensed and form the beta unsaturated aldehyde. Okay, so we are going to condense it in the presence of one acid. So I am writing CH3, COH, CH2, CH. Okay, so what are we going to do? We are going to expand it and somehow find one water molecule to get placed from here and one double bond will be formed. Okay, so it's all happening under H, that is one acid. So we are going to produce one molecule, that is CH3, C double bond H. You can write C H, C double H. This is your final product. This is your alpha beta unsaturated compound, or you can say aldehyde. This is your alpha beta unsaturated aldehyde, and this is our final product. So this is your simple Aldol condensation. Okay. In the case, why we are discussing importance of alpha hydrogen, your alpha hydrogen is very reactive molecule. That's why it is important to have in this reaction. And why it is very reactive, according to when we studied in chemical bonding chapter, we know about reactivity series, and in this our aldehyde group is attached to it. So this is a carbonyl group which is electron withdrawing in nature. It is highly electron withdrawing. That's why this hydrogen become very reactive, highly acidic and very reactive for the reaction. And it actually forms resonance stabilized conjugate base structure when it is released. Okay, so when it is released, it forms a conjugate structure which is resonance stabilized. Okay, so moving on to the next topic. This is your Aldol condensation. We are going to discuss about the next topic, which is cross Aldol. It's nothing different than Aldol, but here we are not going to consider both molecules as single. So we are going to consider one. Let's say one CHOH. This is your one molecule. The other is one is formaldehyde. The other is acetaldehyde. Okay. So this is like that. What I am saying here, one molecule has alpha hydrogen. The other have no alpha hydrogen. Okay. So this goes through cross Aldol reaction and it forms one alpha beta your unsaturated aldehyde. So how it is going to react? How it is going to react? Very important. This won't happen in alpha hydrogen. In case of ketose also somewhere you are not finding alpha hydrogen. The other has alpha hydrogen. In this case, your Aldol condensation goes through cross Aldol. Okay, cross Aldol. This goes through in the presence of one alpha hydrogen at least. Otherwise, it's not going to proceed. So we are going to write the first part, and the first part is going through reaction. The first part of reaction which is going to react with your base, that is your alpha hydrogen part, not the other part. We don't have alpha hydrogen. So the alpha hydrogen part will be reacting with OH minus, and this again form the same component which is I already told you. This is going to form a nucleophile. There is no, and one water molecule is produced plus your nucleophile, which is this. Okay. Your other molecule doesn't have a alpha hydrogen. Okay. So what we are and it is going to break into the polarity of plus and minus. Okay, your nuclear form is going to attack here and form the aldol product, and which is CH. Fine. We have this 2. Okay, here it is again. So again we are going to break hydrogen, hydrogen. Then what happens? One hydrogen going to take from that side. Again the same old process we have done here. It is already broke into OH minus, so we are using one hydrogen and it going to release one water molecule, and your one double bond will be formed here. Okay, so we are going to write CH2 CH CH. Okay, so this will be your final product, that is your beta unsaturated aldehyde, and this is your product of cross aldol. Okay, you can write it according to the IUPAC name. You can write it like 1, 2 or 3, then you can name it like 3 propane, 1 all, something like that, and this is your final cross aldol process. I hope you understand.